Okay, Unit 1, Lesson 8. We're going to find the LCD of rational expressions, and of course, LCD we know means least common. Well, if I could write denominator. So we're talking about finding the smallest possible denominator when we're looking at two separate fractions that each of the fractions could share. And then we're going to add and subtract rational expressions. Well, actually, we're going to add and subtract rational expressions first because we're going to look at some basic examples where they already have a common denominator. So, for instance, let's say you have 5m over 2n, and we want to add to that m over 2n. Well, these two fractions already have the same denominator, 2n, so we can just add straight across. Now, please remember, from just regular fraction addition, when you add fractions, you never, ever add the denominators. So these two n's, we're not adding. We're saying we have how many pieces out of these 2n total pieces. Whenever I'm adding fractions, I go back to the pizza example. I'm going to attempt to draw a pizza here that, well, okay, that pizza got a little lumpy. Sorry about that. Why did my pizza just disappear? I honestly do not know. Let's try this again. Okay, now my pizza got ovular. Alright. Okay, this is a 3D look at a pizza. There's a pizza that's in 8 pieces. Well, if I eat 2 of these pieces, sorry about that, my tablet keeps playing games on me. If I eat 2 of these pieces, so I'm going to eat this one and this one, and then my friend comes over here and he eats 3 of these pieces. Okay, well, how many pieces have we eaten? Well, he ate 3/8. I ate 2/8. So altogether we ate 5 of the 8 pieces. Notice the 8s did not change. They did not change. He ate 3 out of 8. I ate 2 out of 8. Together we ate 5 out of 8. That's a bit of a silly juvenile example, but it gets the point across that when you're adding fractions, the denominator never changes. So back over here to our example, where I have 5m plus m, well, that's going to be 6m. 6m over 2n. And whenever you add fractions, you should always look to see, can this thing reduce? Yes, this thing can reduce because we've got a 6 on top and a 2 on the bottom. And we know that those are both divisible by 2. 6 divided by 2 is 3. 2 divided by 2, well, I'll just erase it. How about that? I don't know why it just erased itself. Again, my pen is playing games with me today. But 2 divided by 2 is 1. So I can rewrite this as 3m over 1n is the same as just n. So there's really no reason to write the 1. And there's my final answer, 3m over n. Let me erase this pizza before it makes me any hungrier. Okay. What's next? Let me give you one that looks slightly more complicated. 3x squared plus 2x over x minus 1. Now, that doesn't look like much fun. And then we're going to subtract, subtract. This is going to be key. 10x minus 5 also over x minus 1. Well, again, these two fractions have a common denominator. I don't need to do anything else to them. I can go ahead and subtract them. But that minus sign is important. Okay, we know whatever we have is going to be over x minus 1. I know that's my denominator. It's not going to change. But now when you subtract, Obviously, we're going to combine our like terms. Well, I've got an x squared term over here on the left, this 3x squared. I don't have any x squared on the right, so I can just come on over here and say, well, I know I'm going to have 3x squared. I know that is going to be there because I don't have anything to combine it with. Well, now I do have x's that I can combine. These two are both x terms. 2x minus, key term, it's minus, not plus. 2x minus 10x is minus 8x. And now, this is the part that people usually get wrong. Let me extend this fraction bar a little bit here. They see this minus 5 on the end, and you say, well, okay, we don't have anything to combine it with, so it must just be minus 5. But what you're forgetting is this minus sign over here applies to the entire second fraction. So when you're looking at this, what you need to think is this 10x minus 5 is in parentheses. And we have to subtract 10x. We also have to subtract negative 5. Well, when I say minus negative 5, you know that's going to make it a plus 5. So, in essence, what happens is when you have a subtraction, whatever's being subtracted, you're going to change the sign of everything on top of that fraction. So the 10x became negative, the negative 5 became positive. And there's my answer. I can't really do anything else with that. I know it doesn't look simple, but that is simplified because we took two fractions and made them one. Okay, let's scroll down here so we can get a little bit more space. Now let's talk about LCD. Those two were really basic examples because you just had a common denominator already. Well, let's look at, first of all, an example with just numbers because this will maybe bring it back for you. If I gave you 1/8 and 3/22, okay, those two fractions do not have the same denominator. If you were wanting to add them, you could not add them right now. You have to find a common denominator first. So in other words, we have to find what is the smallest number that is a multiple of 8 and is a multiple of 22. Well, I've got a cute little device for doing that. Call this the LCM machine, or the LCD machine in this case. If we write these numbers out, and you may have seen this before, it's not like this is my method, I won't take credit for coming up with it. It certainly has been around for a while. We can write these numbers and put a little upside down division bar, and what I'm going to do is I'm going to divide them by primes, only by primes, until there's not a prime that will go into both of them. Well, right now, 8 and 22 are both divisible by 2. 2 is a prime number, so we can use 2. 2 goes into 8 4 times. Why do I keep doing this? I have no idea why things keep disappearing on me. 2 goes into 8 4 times. 2 goes into 22 11 times. Right? Right. Of course it does. Now, 4 and 11 don't have any factors in common. I can't do anything else with it. So, what I do is I multiply all of these numbers that are along the outside here to get my common denominator. So my least common denominator is going to be equal to 2 times 4 times 11, or 88. Sorry, that equals sign turned out a little wonky. 2 times 4 times 11 is 88. So what we're saying is 88 is the smallest number that both 8 and 22 go into. Hey, looky here, I lost my 3 over here too. How long has that been gone? I don't know, I didn't even notice. I'm sure y'all noticed. I have no idea what buttons I am clicking to make these things disappear. It's a grand mystery. Okay, that one was fairly straightforward, but now people's brains sometimes go to mush when I start introducing variables into it. Let me get a little squiggly line in here to separate this, because I kind of am fond of squiggly lines myself. Okay, so let's see, I've got 6 over 15x squared, and I've got 7 over 5x, and I want to know what is the least common denominator. Okay, when you have denominators where there's a variable and there's a constant term, so we've got numbers and variables, just look at the variable part and the number part separately. So first, let's look at 15 and 5. So for my LCD, I'm going to consider each of these separately. Well, 5 will go into 15. So that makes it pretty easy. Our least common denominator is going to have a 15 in it. Okay? Because 15 goes into 15 and 5 goes into 15. Obviously, the LCD cannot be smaller than at least our biggest term. Okay? Because the biggest term cannot go into anything smaller than itself. So now let's look at the x's. Over here, if I were to break this down, this 5x, you'd say that's 5 times x. If I were to break this one down over here, 15 is 5 times 3 times x squared is x times x. Well, I already took care of the 5 times 3. That's 15, right? So I've got a 5 in my LCD. I've got a 3 in my LCD. 5 times 3 is 15. Well, now I've got 2 x's here. I've only got 1 x on the 5x. But I have to use each factor the most number of times it appears. X squared can never go into x. Now, you can't multiply x squared by something and make it become x. Unless you're using 1 over x, and that would just be silly. But I can multiply x by something and make it x squared. So what I'm going to do is I'm going to take x squared and put it over here. And my LCD is 15x squared. Now that one was kind of interesting because our LCD just happened to be one of the denominators, 15x squared. But that's because if you look at this 5x, what would I need to multiply it by? If I came over here and multiplied it by 3x, pretend that's an x, well then suddenly this is the exact same as this. So what we're saying is we could make this denominator on the right become the left denominator just by multiplying by 3x. And the left denominator, the 15x squared, we wouldn't have to do anything to. It's just going to multiply by 1. It's going to stay itself because it's perfect just the way it is. Okay, clear as mud? Of course it is. Let's look at one more of these like this. So let's go 7x over x plus 2 and 5x squared over x minus 2. Now notice when we're looking at the LCD, we don't even care about the numerators right now. We don't care what's on top. We only want to know what do we have to do to the bottom of the fraction to make it the same. Well, in this case, I could put parentheses around this. I think it sometimes helps to see them in parentheses. Sorry, let me get rid of that one. That was an ugly parenthesis. That time I made it disappear on purpose. Okay, x plus 2 and x minus 2. Well, these don't share anything in common. Okay, we don't know what x is. Doesn't matter what x is. Because these are not going to be the same things. Pick a value for x. Pick 0 for x. Well, then this one over here is 2 and this one's negative 2. If x is 3, then this one over here is going to be 5 and this one's going to be 1. So the point is these could be very different based on what x is. We don't know yet. But what we know is x plus 2 and x minus 2 are two different factors. They don't share anything in common. So our LCD has to have both factors in it. So our least common denominator then is just going to have each factor. It's going to be x plus 2 times x minus 2. And that's all there is to it. Because we can't do anything else. We can't eliminate either of those factors. Think about what you would do. In this fraction right here, x minus 2, well, I could multiply by plus 2 on the top, x plus 2 on the bottom, and by multiplying by the same thing on top and bottom, I have not changed the value of the fraction. I really just multiplied by 1, x plus 2 over x plus 2. But now I've got this least common denominator I just talked about. Well, now if I come over here to this other fraction, I could multiply it by x minus 2 on top and bottom, right? And now it has the exact same denominator. So now their denominators are the same. So that's what we mean by the least common denominator. X minus 2 times x plus 2 is the smallest possible denominator that they could share, that they could each have. Okay, time to move on. Time to move on to actually doing some math. Now, if we want to add and subtract fractions that are not alike, in other words, that their denominators are not already the same, well, we have to go through this process we've already done. Okay, let me write it out here. To add or subtract fractions without common denominators. Well, that's a funny statement because we can't add or subtract fractions without common denominators. Well, that was supposed to be a colon. Let's see if I can make it work. Okay, well, step 1, find a common denominator, preferably the least common denominator, because that makes you do the least work possible, and of course we don't want to deal with bigger numbers than we have to. Okay, well then after we know what the least common denominator is, you kind of saw me do this as an example on the last problem, we want to rewrite each expression or each fraction with the new denominator that we found in step 1. I'm sure you enjoy hearing the clicking of my pen against the screen incessantly as this goes on. Okay, well, now that we've done that, we can actually add or subtract whatever the problem calls for. Add or subtract and write the result as one fraction. We're taking two fractions or more and making it into one. And then last important step, if you don't do this, you're not done. Simplify. If possible. I'll put in parentheses because it's not always possible. Sometimes you cannot simplify. How dare me give you one you can't simplify. Actually, you'd probably like that because that means less work for you. So, there's our steps. Okay, let's look at one. Let's look at a really basic one. A over 4 minus 2a over 8. Okay, I'm sorry. My A got a little weird tail there and it turned into a Q. I don't know what happened. I have no excuse for myself. Let me fix that. That's going to bother me. Slightly better. Okay, so we have a over 4 minus 2a over 8. Looking at the denominators, we've got a 4 and an 8. Hopefully, it's pretty clear to you that in this case, our least common denominator is just going to be 8. 8 goes into itself, 4 goes into 8. So what do I need to do to make this 4 become an 8? Well, what I need to do is I need to multiply it by 2. But if I multiply it by 2 on the bottom of the fraction, I have to do the same thing on top. If I don't do the same thing to the top and the bottom of the fraction, I've changed the problem completely. So then what do I have now? Now I have 2a over 8 minus 2a over 8. Now, what is that going to be? I don't know, man. You don't know what it is. You don't have to know what a is to answer this. 2a minus 2a is 0. It doesn't matter what it's over. Well, 0 over 8. What's 0 over 8? 0 over anything is the big squadoosh. Nada. Those two cancel each other out. 2a minus 2a is 0. Doesn't matter how many pieces you have. Think about the pizza example again. If you have 8 pieces, or you have 16 pieces, or you have 12 pieces, it doesn't matter. If you've eaten 0 of them, you've eaten 0. Pardon me, I had to drink some water. I'm just yakking to myself too much here and my throat's getting all dry. Okay, let me look at one that's going to challenge you a little bit more. I really need to make some more room here. Not like that. No, give me some more space. More space, thank you. Okay. Let's say you had 6x over x squared minus 4, and we want to subtract 3 over x plus 2. Okay. We've talked about factoring polynomials already. You should notice, hopefully you notice, that x squared minus 4 is a difference of two squares. So I could rewrite this as x plus 2, x minus 2. That's the factored form of x squared minus 4. Anytime you have expressions in your denominator that look like they could be factored, try to factor them. You need to, because you've got to know what factors you're working with. It's just like with whole numbers. If I have two whole numbers, I'm going to factor each of them to see what they have in common. Well, we need to factor these expressions, these polynomials. So if I rewrite this, let me rewrite the whole problem. I've got 6x over x plus 2. Darn, my pen is not working with me. What is the deal? I have no idea. Just a second, let me get this fixed. Let's try this again. I really don't know why it's not cooperating today. Times x minus 2. X plus 2 times x minus 2, right? And then we're subtracting. No, we're not, because it's going to delete it as soon as I write it. 3 over x plus 2. And let me go ahead and put that x plus 2 in parentheses just to make it look the same. So, what do you notice? Well, what I notice is I've got an x plus 2 here and an x plus 2 here. So this should be pretty easy. All I need to add to the right fraction is this x minus 2. If I had an x minus 2 in the denominator, then they would be the same. So that's what I'm going to do. I'm going to multiply by x minus 2, and if I do it on the bottom, I've got to do it on the top. We'll put a little multiplication dot in there. So now let's come down below and see what we have. I have 6x. Now, this is where you really got to be careful. This is a minus sign. And I think at this point, since we're about to have a 3 we need to distribute, you might do well to think of it this way. This minus 3 is the same as saying plus a negative 3. Alright, you with me? You with me? Okay. Because all I did is I rewrote it. What I'm saying, let me come over here and say it. I'm saying negative 3 is equal to this. They mean the same thing. I could do minus 3 or I could do plus a negative 3, and they mean the same thing. The reason I did this is because I wanted to have this negative sign attached to the 3, because now I'm going to distribute this negative 3 to get rid of my parentheses on top. So what I have is negative 3 times x, well that's a negative 3x. And negative 3 times negative 2, well that's a positive 6. And all of this is over my common denominator of x plus 2 times x minus 2. I went ahead and wrote them as one fraction in this step. Since I got the common denominator, I could go ahead and do that. Well, let's simplify. There's some definite simplifying that can happen here. On top, let me give myself a little bit more space. I'm going to erase this plus and minus thing that I just put over here. Never mind my talking to myself. At least I'm not currently talking to myself in voices, which could happen at any moment. You never know, because in just any moment I could turn Irish, hop across the pond. Hey, so if you look at the top of the fraction, you've got 6x minus 3x. Well, that's just 3x. And then I've got a plus 6 on there. And all of this is over x plus 2 times x minus 2. Do you follow me? I hope so. Now you might think you're done, but you're not. You know why? You can factor the top of that fraction. 3x plus 6. Both terms are divisible by 3. Let's do it. If I factor out a 3, what does that leave me with? It leaves me with x plus 2. Well, isn't that nice? Because now I've got x plus 2 on the bottom and x minus 2 on the bottom. Now, since we're multiplying everything, x plus 2 cancel each other out. And my final answer is 3 over x minus 2. And now you jump for joy. Alright, that one took a few steps. But what I want you to notice is, don't think you're done until you know you have tried to simplify everything. If you stopped with 3x plus 6, then you would have not gotten the last couple of points on this problem. Or if you're entering it online in my math lab, you wouldn't get it right at all because they don't give partial credit. So there's that to think about. Okay, let's do one more and then that'll probably be good. Let me see. 2 over 3t plus 5 over t plus 1. Okay, we've got one of our denominators is 3t, one is t plus 1. They share nothing in common. You might say, but they both have a t. Yes, but remember, you've really got to consider this t plus 1 as one factor, one term. It can't be pulled apart. Okay, so what do we have to do here? Well, we're going to have to just multiply by each denominator to get our LCD. So in other words, the LCD here is just going to be 3t times t plus 1. My t got a little wonky there. Oh, now it got even wonkier. Oh, sorry about that. That is an interesting looking art piece that I've just created accidentally. So what am I going to do to get that common denominator? Well, in my first fraction, I have the 3t. I don't have the t plus 1. So I need that on top and on bottom. In my second fraction, I have the t plus 1. What I don't have is my pen working. That's what I don't have. I don't have the 3t. And at this point you're wondering, why does he keep using this thing? It doesn't work. I'm hoping that it's going to start working a little better. Working the kinks out anyway. Okay, let's see what we have now. On this first fraction, I won't combine them yet. I am going to, yeah, I'll just leave the t plus 1 first. It really doesn't matter which order you write the factors in. And the 3t does not have to be in parentheses. I just wrote it in parentheses this time. Now up here, I've got a 2 that I need to distribute. 2 times t is 2t. 2 times 1 is 2. Okay, and then I'm going to add to this. 5 times 3t is 15t, and all of that is over t plus 1 times 3t as well. Now this time, I've got a common denominator. Let's go ahead and combine. Well, what can I combine? I can combine my like terms. 2t and 15t. They both are t's. Together that gives me 17t plus 2. That plus 2 is still there, don't forget about it. All of that over t plus 1. There, my t got wonky again. Times 3t. Again, the 3t doesn't have to be in parentheses, but I'm just leaving it there for now. And believe it or not, that is your final answer. You really can't simplify that. Okay, I said that was going to be it, but let me do one more quick one because I know you're going to see one like this and I want to have at least shown you one. 7 over x minus 3 minus 9 over 3 minus x. Now, interesting. What do we have going on here? If you look at the denominators, you got to be kind of clever to pay attention to what's going on. Well, if you factored a -1 out of the second fraction, you would have the same denominator as the first fraction. Let me give myself more space here. What I'm saying is, we've got 7 over x minus 3 minus 9 over -1 times, well, if I pull a -1 out of a out of a 3, that makes it a -3. If I factor a -1 out of -x, that makes it a positive x. Well now, isn't this interesting? Because what do I really have going on here? Well, I can take this -1 and ship it up to the top. Negative, that's not going to change the value. Where you put the negative, top or bottom of the fraction, doesn't change anything. So now what I have is 7 over x minus 3 minus -1 times 9 on top over, well now, what if I just rearranged the order these were written in? -3 plus x is the exact same as positive x minus 3. Well, now I have the exact same denominator. Ain't that fun? So I don't have to do anything else to it. So what do I have then? I've got 7 minus -9 over x minus 3, which is the same as, I hope you know, 7 plus 9 over x minus 3. So my final answer would be 16 over x minus 3. Isn't that crazy? So what I'm saying is, when you see a problem that looks like that right there, where you've got an x minus 3 and then a 3 minus x, or whatever the number is, pretty good bet. Just factor a -1 out of one of them, and then you're going to have a common denominator already. Okay. Now, you may see some that don't look exactly like this. You may have to do some more factoring, but just pay close attention to how you have to factor, and if you get stuck on any, feel free to email me, call me, do what you got to do to get it figured out. Don't forget you can look in your textbook and watch her videos if the publisher has any videos for specific problems also. Alright, I think I have gone on long enough for this particular set of notes. Good luck on the assignment.